Okay, here we go with round two. So we left off with a little derivation, if you will, of a derivative. A derivative derivation. So we found out how to find cotangent of x. I think you could probably imagine us doing that for tangent of x. You could change that to sine over cosine. And again, do the quotient rule. You could do this as 1 over sine, right? And then do quotient rule. That one works out really nicely because the derivative of f is 0. Same thing with secant. We can easily do that. So maybe we'll do that next class when I'm back with you guys. But let's. I'm going to turn the page. I don't have any space at the bottom. If you got the same situation, let's go ahead and move on to the next page. We need about 5 lines for the next problem. So we're not going to call it example 2 though. We're going to call it 2.5 evens. And the first one we're doing is number 2. And they've given us the following function. F of x equals 5 over x squared plus sine of x. So this is kind of a hybrid, little algebra trig stuff. My first thought is just a rewrite. I'm not digging the 5 over x squared style, so we'll do the usual, like we've been doing the last few days. And then, of course, we've got our new trig mixed in there. All right, so that seems pretty simple. So don't put an equal sign here. You can just come down to the next line if you want. I'm going to try to use this space over here. So f prime of x, well, let's see. You're going to do your power rule on the first part. So the negative 2 comes down, joins the 5. That'll be a negative 10. X to the negative 1 or negative 3, and I choose negative 3. Negative 1 doesn't make sense. Reduce, subtract 1. Next, we know the derivative of sine of x. In fact, I've got my little cheat sheet right here. Check it out. And I would recommend you do the same thing. Make yourself a little post-it note. Just quick little derivatives. Practice, practice, practice until you no longer have to look at them. So the derivative of sine x is cosine of x, and we are done. That would be it. That would be your final answer. So I'll take that as a final answer. But of course, in practicing all the different forms, maybe you want to rewrite it like that. So give me 2 forms right there, and we are done with numero dos. It's time for number 4. This is where I would say, do you have any questions? But I can't hear you. So I'm going to keep going. And if we could have the substitute pause anytime it seems like we're going too fast and they would like you to stop it, just pause it, let them catch up, and then continue once they're ready. All right, so the second function for number 4 is sine squared of x. Now we have a new technique coming up on Friday when I return called the chain rule. Some of you maybe learned that at the UCR session back in September. We haven't learned it yet, so right now we have to break this down into a different form. Maybe that looks familiar to you. That looks to me like an F and a G. And as just a nice little convention to follow, if this is already called little f, don't call this little f because that's confusing. That's ambiguous. So we're going to call this big F and big G. But it still works. We're still going to do gf prime plus fg prime. So yep, we're going to do some product rule right now. So f prime of x, we're going to go g, that's this guy, times f prime. What's the derivative of sine? Oh yeah, it's cosine. Plus or minus, well, this time it would be a plus, right? Because it's a product rule, not a quotient rule. And then we need, let's see, if that's g and f prime, we'll need f and then g prime. And you'll notice these are identical because f and g are the same thing. It's just sine of x both times. So hopefully you see this. That's one of these sine x cosine x's and another one of those sine x cosine x's. That's 2 of these sine x cosine x thingies. And that's a pretty good looking answer right there. But if you know your double angle formulas, in fact, if you could find them, they're on the wall, right next to the clock. You'll see the double angle formulas in brown on a poster. And hopefully you can see it by now. This is sine of 2x. If you recognize it, you need to be able to change that. I just realized the way I wrote that, it kind of looks like a fraction. It's not. It's either this answer or it's that answer. And I'm guessing if it's multiple choice, they'll probably have you try to find this answer, sine of 2x. All right, let me move my cheat sheet out of the way. We'll bring it back down if I need it. Actually, let me just stick it right there, then I can kind of see it. as we do our number 6. All right, moving on to number 6. We're going to keep on cruising. Next up, we've got f of x equals sine of x over x squared plus sine of x. Now, there's probably a temptation to do some canceling right here with the sine of x. But we talked about this last time. If the bottom is a monomial, you know, if this were flipped upside down, you could split this into 2 fractions. But here, the bottom is a binomial. It's not even a binomial. It's a two-termed expression. You can't split it into 2 fractions like that. So instead, we're just going to jump right in. And I see some stuff on top, some stuff on the bottom. Sounds to me like quotient rule is in order. So here goes. We'll start with the bottom. That's easy. You just copy it down and square it. That's your g squared. Remember your quotient rule. It's going to go gf prime minus fg prime all over g squared. So here goes g and f prime. We know the derivative of sine. It's cosine. Minus, now we have f times the derivative of g. It's 2 terms here, so we'll break it up and do derivative of x squared is 2x, and derivative of sine is cosine of x. So far, so good. If this is the AP exam, you are done. So preliminary boxing up, but we ain't done. We're going to keep on going. We're going to simplify somewhat here. Let's go ahead and distribute here and distribute there and see what it all turns out to look like. I'm just going to keep going, try to keep up. I've got a minus sine x 2x, and we'll usually put algebra in front of trig. So I'm going to go minus 2x sine of x. And then we have a plus times a minus. That would be a minus sine x cosine of x. Ooh, look at that. Do you see what I see? All right, on the bottom, don't mess with this at all. This is perfect the way it is. Don't FOIL this out. Rarely will we multiply the bottom out. Okay, what I was talking about earlier, do you see what I see with my lame singing, is those guys are identical except for their signs. So say goodbye to them, and let's go ahead and rewrite what's left behind. I see an x squared cosine of x. I see a minus 2x sine of x, and it's all over this mess of a denominator. And at this point, we would probably stop right here. I'm sure there's some other ways to write this, but at a certain point, you just stop doing that because you realize it's not really getting you anywhere. If it's not becoming simpler, we'll just stop. Number 8 coming up. F of x equals the quantity x squared plus 1 times secant of x. Now we know the derivative of secant of x. If you remember, I had a special name for this one. It started with an r. Do you remember it? R for the repeater. Right? You repeat the secant x and then you come back with a tan x at the end. So I'm seeing a product rule. Some of you might be tempted to distribute the secant x first. I think that's just going to make it messier. It would work, but we're not going to worry about that. We're just going to do it straight up as is. So here goes. That's like an F and a G. Let me go ahead and label those over there. It's a product rule. So we're going to go G, F prime, plus F, G prime. And please notice my use of beautiful parentheses everywhere. Every pile gets its own parentheses. I've got my clear plus sign in between. It's not a quotient, so it's not a minus. It's a product, so you get a plus. And let's see. If we reorder this and drop the parentheses, algebra before trig, and then let's see. We can leave this as is for a moment. That would be a pretty decent answer right there. So let's go ahead and box that one up. That would be a preliminary boxing. And let's see, can we rewrite this a little bit more? Can we distribute that to this and to that? And of course, the answer is yes. Is it going to be fruitful? Is it going to be helpful? I don't know. So we'll have x squared times the stuff, the trig stuff. Then we'll have 1 times the trig stuff, which is just the trig stuff. So that's a pretty good looking answer as well. And I guess we could go a step further. Do you see anything that all three piles have in common? They don't all have an x. This one doesn't have an x out front. They do all have a secant. Did you see that? If you did, hooray. If not, it's cool. So we'll factor out that secant of x. We'll leave a 2x plus x squared tan x, and then a plus tan x, and that's probably good enough for that one. Again, these are tricky to try to figure out where do I stop, right? So a good rule of thumb is, hey, you're not ready for the AP exam yet, so keep on practicing different ways to write things. And remember, the back of the book or the solutions I post may have one form of an answer. You may have a different form, and they could be different, and that's fine too. So, all right, let's go ahead and move on to number 10. I don't need a lot of space for number 10. Let's call this f of x equals cosine of x minus x cosecant of x. This one looks a little scary. I've got a product rule, but I'm also subtracting from some other function. But we talked about some rules. If it's separated by addition or subtraction, you can just straight up take the derivative of that by itself. And I know that one. It's right here. So then over here, I need to make a decision now. I'm thinking leave the negative out there, and here's my product. And that's a little f, or a big F, and a big G. So I'm going to go minus, and I'm going to go do a big old product rule thing over here, off to the right. So here goes. G, f prime, derivative of x is 1, plus f, g prime. That's a repeater, but it's the negative repeater. So derivative of cosecant. And don't feel bad if you don't know these yet. I understand that. You're just going to keep referring back to it. That's why I put this slip right here. So it's going to be a negative repeater. One of your jobs for your homework, I'll tell you this now because I might forget to say it later when I write down the assignment. One of your jobs is just to have these, all 6 of them, memorized, right? No ifs, ands, or buts about it. You memorize these. Make some flashcards, do what you got to do, test each other, have your parents test you on them, make sure you know them. All right, let's go ahead and distribute that negative and break down all the walls. So we don't need any brackets, no parentheses. 1 doesn't do anything. Then we have a negative times a positive times a negative. That's a positive. And we'll have x cosecant x cotangent x. So there we go. That's a pretty good looking answer right there. In fact, I'm going to box it up right now. So then I would ask you, do they all three have something in common? And you can't say x. You can't factor out an x and leave sin or cosecant without an x. It doesn't make sense. So sine needs an x. Cosecant needs an x. So you don't get to take those away. Let's leave that one. I like that one as is. All right, I'm going to take a short break. Now would be a good time for you guys to take a short break. Maybe finish copying what it is you need to get copied on this one. If we need to back it up, pause it, back it up, that would be good. I'll be back in just a minute.